Hello! Today Christina and I are going to be talking about the energy transfer of jumping on a trampoline. First, we are going to look at a single person of weight 1 jumping on a trampoline. As you can see here, person 1 jumps to a maximum of height 1. Now we are going to look at another person of weight 2 jumping on the same trampoline. As you can see here, person 2 jumps to a maximum of height 2. Here we will see person 1 and person 2 alternating jumps. Person 1 jumps to a height of height 1. Person 2 jumps to a height of height 2. Finally, we are going to look at a double bounce. First, both person 1 and person 2 are just alternating jumps. As we said before, person 2 jumps to a height of height 2. But then, person 1 jumps slightly before person 2, which causes person 2 to jump to height 1 plus height 2. The reason for this will be explained next.
Now we are going to do the work energy analysis of a double jump. In order to do this, we are going to analyze two different cases where two different people are jumping on a trampoline separately, and we're going to find the height that each person goes and add them together to simulate a double jump. The reason this will simulate a double jump is because in a double jump, one trampoline and all its springs are stretched for the amount of two people's masses, but only one person experiences the force of these masses. So by getting each height and adding them together, we will be finding the height that one person would go in a double jump. So in our start diagram, we start right when the person is being thrown back up into the air, so they have initial velocity and a base height. In our end diagram, we are seeing how a person goes from base height to their maximum height with a final velocity of 0 because they are at max. So we have three assumptions. So VF is 0 because they're at max height, HO is 0 because it's our base height, and X final is 0 because we are also assuming that the springs revert to their natural length when it is in the end stage. So now we can do our work energy equation. And by taking work energy and expanding it, we are left with this equation. So now if we want to solve for HF, we complete algebra and are left with this equation. So this would be for one person jumping on a trampoline by themselves. In order to have two cases, we must add subscripts to show the differing values. So there is one work energy equation for each person. And now by doing that, we have two equations to show that the heights are different, masses are different, velocities are different, and the amount the spring stretch is different. And to get the total height, we must add these two equations together. So H1 final plus H2 final is equal to this. And this is the height that a person completing a double jump would go because all of the energy is transferred to them.